Hello world. In today's video we're going to be going through some application of calculating the resultant of two or more vectors that are not perpendicular and that are not even collinear. Okay, so please note that this question was obtained from the Kutonong Pro Maths program slides, hence you are seeing that up there. And this is typically how these questions are asked in an exam or a test. Even the previous examples that I have provided, they give an idea of how these questions could be structured. So today's question, we are given the forces A, B, C, D, which act at a common point O as shown in the diagram. And we are told that the magnitude of these forces are 5 Newton, 8 Newton, and 6 Newton, respectively. But before I continue, please feel free to pause the video and try out the question on your own, and you'll unpause to check the answers if they are correct. Okay, so we are told as well that D has an unknown magnitude. If we look at D, there's D over there. We are given the angle, but not the magnitude of the force. So the first step, what I'm going to do before I even go to the questions, I am going to analyze this problem as thoroughly as possible. So I'm first going to classify these forces as being 1D or 2D. If I look at A, it's between the Y and the X axis, so this is clearly a two-dimensional vector. If I look at B, B is along the horizontal axis, that is a 1D, this is a 2D, and finally this is a 1D. Remember those steps that we discussed. For your two-dimensional vectors, you are going to draw out their components. I'm going to start with A. With A, I first need to go upward, and then finally move towards the left. So this will be AX. You can call it FAX. It's fine. This one will be AY, and the components are perpendicular to each other. And when I get to the force D, I need to move downwards and finally move towards the right. So this is dy, or you can say FDY, and this one will be dx, and they're perpendicular to each other. So if I were to draw out this sketch nicely for myself, then I would have the following. I have AY pointing upwards. This is my AY. I have DY pointing downwards. There's DY. What else do I have? I also have C pointing towards the right. So this is C. I also have B pointing towards the left. That is my B. And finally, I have AX. So this is AX. Oh, sorry, AX. So we can clearly see from the diagram that the orange vectors, they are collinear, and the maroon ones, they are collinear. Okay, so now I can complete the sketch by including the magnitudes. I'm going to start with the ones that I have. For B, I know that the magnitude there is 8 Newton. For C, I know the magnitude is 6 Newton. Oh, and I'm missing one more component. My apologies. I'm missing the component of D along the X direction. So I'm going to have dx there. So if I look at dx, we need to figure out what the components are going to be. So remember, we use the trigonometric ratios to calculate the magnitude. So I'm going to just start by defining sine of 30. Sine of 30 degrees is opposite to what's on the opposite side. That is dx. That is dx divided by d. If you cross multiply, dx will be equals to d sine of 30. So far, we don't know what d is, so I'm just going to write the expression. So we have d sine of 30. Remember, we said in the previous video, if one component takes the sine ratio, then the other one will take cos. So it means that dy will be equals to d cosine of 30. You can verify this for yourself. Okay, now we are left with the components of A. I'm just going to start by defining sine of the angle within the right angle triangle. If you look at that angle, I'm going to call it alpha. It has not been given to us. We are only given the angle from the positive x-axis to the vector A. So if we want to figure out what alpha is, we know that from the x-axis to the y-axis, let me erase that a little bit. We know that from the x-axis to the y-axis, we know that angle is 90, but we are given this whole angle as 150. This tells us that alpha plus 90 need to give us 150 degrees. Therefore, alpha will be close to 60 degrees. So alpha is 60. Sine of 60 degrees is equals to the opposite, which is ax over the hypotenuse. A cross multiply, ax will be a sine of 60. So ax is a sine of 60. If the x component takes sine, it means the y component will take cos. So it means that ay will be a cosine of 60. But what is a? A is 5. So this is equals to, this will be 5 cosine of 60. 5 cosine of 60 will be 2,5 Newton. That will be 2,5 Newton over there. And we can use the calculator to figure out what AX is going to be. This is my calculator. So for AX, that will be 5 sine of 60. 5 sine of 60, my calculator tells me that will be 4,330. So that will be 4,330 Newton. And I'm just going to clear my sketch a little bit. Okay. So now looking at this new diagram, we have most of the things. Yes, we have most of the things. We have done a very thorough analysis. So we can now go to the questions. If we look at the questions, the first one says define resultant. If we define a resultant, this is a sum of two, a vector sum of two or more vectors acting together. According to the examination guideline of grade 11 2015, you can define the resultant vector as a single vector that has the same effect as two or more vectors combined. The other one says calculate the magnitude of the resultant of force B and C. Let us try to locate the forces B and C. If we go to the original diagram, there's B over there and then there's C over there. And we can clearly see they're along the same straight line, so they are collinear. Collinear vectors, we just add them together, take into account the direction. So RBC is the resultant of B and C. That will be B plus C. I'm going to take right as positive. If I look at B, it's pointing towards the left, so that is -8 plus the other one will be +6. Punch on a calculator, you get -2. So the answer there will be -2 newtons. The negative is for direction, but if you read the question, it says the magnitude. So that will be 2 Newton. The magnitude is 2. But when you write out your solutions, just make sure that the solutions are as detailed as possible. Write everything. Okay. Then the next question says the net horizontal component of the forces A, B, C, and D is equals to 1,25. And if you look at the sketch that we have just simplified, along the x direction, we indeed have 1, 2, 3, 4 forces. So what this means is the resultant of the forces along the x direction, that is 1,25. This statement in going forward is going to help us in answering the questions. So it says calculate the magnitude of D. We can clearly see that we don't have these components. We don't have the y component. From the expression of the y component, the magnitude of D appears. So it means if we can find the component of D along the y direction, then we can clearly find the magnitude of D. But that is not going to be any useful because we don't know the resultant along the Y. And if we look at the sum of forces along the X direction, that has already been given to us. So we can use the sum of the forces along the X direction to figure out the magnitude of D. Okay. So by definition, what is Rx? Rx is equals to AX plus B plus C plus DX. Okay, remember earlier on I took right as positive. I'm going to maintain the direction. What is Rx? Rx has been given to us as 1,25. And then what is AX? AX, there it is. The magnitude is 4,33, but it's pointing towards the left. So I have negative 4,33. How much is B? B is 8, but towards the left. So the negative is for direction. Plus C, C is towards the right. So that is positive 6. And I do not know what DX is. So I'm going to punch this in a calculator. I have negative 4,33 minus 8 plus 6. Okay, so this tells me I have 1,25 equals to negative 6,33 plus dx. If I solve for dx, then I need to transpose. I have 1,25 plus 6,33. So that tells me that dx will be equals to 7,58 Newton. So if we look at dx, there's the expression for dx. We already now know what dx is. It means we can use the expression to figure out the magnitude of d. So using the expression, substituting dx into the expression, I have 7,58 being equals to d sine of 30. So to find d, I'm going to divide both sides by sine of 30. So I'm going to have 7,58 divided by the sine of 30. Calculator tells me that will be 15,16 newtons. Okay. Now the last question. The last question says, hence calculate the magnitude. Over here, we are only looking for the magnitude of the resultant forces acting at point O. Remember, amongst the steps, we said we needed Rx, Ry in order for us to find R. But looking at this statement in bold, Rx was given to us, so we don't need to worry about Rx. Rx, we know right now that is 1,25. That is the magnitude and it's positive. It means it's pointing towards the right. So if we look at Ry, do we have Ry? Not yet, but it's something that we can calculate. If we go to the diagram above, along the y direction, we only have two forces. We have AY and DY. So RY will be AY plus DY. That will be equals to, let us see, our AY, we said that was 2,5 pointing upwards. I'm going to take up as positive. Plus, the other one will be negative. The y component over here is d cosine of 30. We found d, that was 7,58 cosine of 30. Let me punch that on calculator. 58 cosine of 30. Aye, that is 7,58 cosine of 30. If I punch that on calculator, this tells me that my answer will be 6,564 Newton. Okay. I'm going to put this over here. So this is negative 6,564. Then if I add those together, I have 2,5 minus 6,564. And then it tells me that the answer is negative 4,064 Newton. And I can draw out these components for myself. The x component is positive. This is Rx, and then the y component is negative, meaning downwards. And then remember that the resultant will be from the tail of the first one, which is Rx, to the head of the last one, that is R. And because these components are perpendicular to each other, it means to find R, I need to make use of the theorem of Pythagoras. It means R will be equals to the square root of Rx squared plus Ry squared. That will be equals to, let us see, 1,25 squared plus, the other one was negative 4,064 all squared. Okay, if I punch that in calculator, I have, okay, let me clear that. 1,25 all squared plus negative 4,064 all squared. Let me try again. I don't know, for some odd reasons I'm doubting that answer. 1,25 squared plus negative 4,064 all squared. Highball. Okay, that is more like it. So my calculator tells me that the value of R, the magnitude of R, will be that value over there. 4 comma, I'm out of space, I'm just gonna write it up there. R has a magnitude of 4,251 Newton. Remember, we are only asked to calculate the magnitude, so we don't even need to go as far as finding the angle theta. That's it from me for today. Thank you. Bye, all.